Here we have another partial fractions decompositions example problem, and we want to evaluate the following integral. And when we look at this integral, the first thing we notice is that we have a polynomial in our numerator as well as a polynomial in our denominator. And the polynomial in our numerator is going to be of a higher power than our denominator. So when we notice this, we know that we'll need to use long division to simplify this expression and then ultimately take the integral. So let's do that. Our first step will be performing long division. So we'll have x cubed minus 3x squared on the outside and our numerator on the inside. And by doing long division, what we'll be left with is x minus 2 with a remainder of negative 18. So now we can rewrite this integral as the integral of x minus 2 minus 18, which was our remainder, over x cubed minus 3x squared, which is what we were doing long division with. The next step is to integrate these first two terms because we know that that's easy, and then perform the integral of the third term. So when we look at this term, we know that we'll have to use partial fractions decomposition because we have a higher order polynomial term in our denominator than one in our numerator. So we can go ahead and do that and set up our partial fraction decomposition with a over x plus b over x squared plus c over x minus 3. And we got these three terms by using our partial fraction decomposition formulas. The next step is we can multiply this denominator through to all three of these terms, and we'll get the following expression. After simplifying, we can go ahead and solve for our a, b, and c terms by letting x equal some value. So we'll let x equal 0 to isolate the b term and get b is equal to negative 6. We'll let x equal 3 to isolate the c term and get c is equal to 2. And we'll let x equals 1 to isolate the a term and get a is equal to negative 2. Now we can go ahead and plug in these a, b, and c constants into our expression, and we'll get the following integral. And this is an integral that's very easy to do. We can go ahead and perform this integral, and by combining our solution from this integral with our earlier solution, we can get our final solution.